Okay, now we do exercise 10.3. I give you a few examples. I start with question 1a. I'll do a quick sketch for you to help you better understand this question. So first we have angle AOC is 128 degrees. AOC. Notice, right, that this is the angle at the center. So simply, if I want to find x, okay, x is ACD, x. Angle at center, angle at circumference. Straight away we know that x is equals to half of 128 degrees is equals to 64 degrees, and the reason being angle at center equals to 2 times angle at circumference. Quite easily solved. Okay, now we want to find angle y, okay, which is down here. Okay, now I bring across to you that this is a cyclic quadrilateral ABCD. A, B, C, and D is a cyclic quadrilateral. All 4 points touch the circumference of the circle, which means that x and y are supplementary. That means together they add up to 180 degrees. So now if I want to find y is simply equals to 180 degrees minus 64 degrees, because these two together add up to 180 degrees. Just take 180 minus 64. Okay, 180 minus 64, I get y being 116 degrees. And just right there, for the reason angles in opposite segments. And that is 1a. Now we will do question 1h. Okay, for 1h we have to find angle x. Okay, now first let's just draw the diagram first. Okay, then we have A, B, C, D, E. Okay, like that. Okay, and we have this angle here, O, which is 58 degrees. Okay, and then we have the angle X down here, and we have the 100 degrees over here. Okay, this question requires just a bit more of thinking. Alright, what we need to do is to add an extra line here, like this. The one in red, there's the extra line. Okay, let me explain what the extra line is for. Okay, you notice that if never mind, we don't talk about the cyclic quadrilateral first. Okay, first I try to find angle ECD. Okay, notice that angle ECD is half of angle EOD, because angle at center EOD is 2 times angle at circumference. So therefore half of 58 degrees will give me 29 degrees. And write the reason angle at center equals to 2 times angle at circumference. There we go. So I'll just label what I have found so far. This angle here is 29 degrees. Okay, now this red line here will help me to form a cyclic quadrilateral ABCE. So I use highlighter. ABCE is actually a cyclic quadrilateral. So it means that angle BCE, okay, angle BCE will be equals to 180 degrees minus angle BAE. Why? Because it's a cyclic quadrilateral, so therefore angles in opposite segments will add up to 180 degrees. So therefore angle BCE, as we will have found, will be 180 minus 100 degrees will give me 80 degrees. So I label down there, this thing here will be equals to 80 degrees. So now x is the sum of these two angles, so x is simply equals to 80 degrees plus 29 degrees equals to 109 degrees. And we have solved question 1h. Now I'll give you one last example, question 3. Okay, and this will be the last of the examples for exercise 10.3. Okay, let me quickly just sketch the diagram first. Okay, you do not actually need to sketch these diagrams in the examination, but if you want to, it's helpful. Okay, I find that it helps me to think better. Okay. Okay, this is 28 degrees. Okay, now first they say AD equals CD, and we also know the angle BAC is 28 degrees. Find angle ADC. Okay, notice that I already on my own I drew an extra line here. Okay, if you notice this diagram, this is a semicircle. So therefore, straight away when you know there's a semicircle, this angle here, angle ACB, will be equals to 90 degrees. Okay, why? Because angles in semicircle equals to 90 degrees. So I write down angle ACB equals to 90 degrees. I say it's because angles in semicircle. Okay, this is the first part there. Then, now, the next thing that we can do down here will be this. Okay, there's a point here, O. Okay, next thing I can do, right, is if this is 28, this is 90, I can find angle ABC. Okay, so angle ABC is equals to 180 minus 90 minus 28 degrees. Okay, so I have 62 degrees. This because it's angle sum of triangle ABC. So right there, angle sum of triangle. So this angle here, let me write it down in red, is equals to 62 degrees. Now, here's where we have this slight trick here. Notice that A, B, C and D actually forms a cyclic quadrilateral. All 4 points are actually on the circumference of the circle. You may not be able to see it, but if you were to extend down here like this actually forms a cyclic quadrilateral. So in this case, angle ADC is equals to 180 degrees minus 62 degrees. So I get 118 degrees. And the reason here being angles in opposite segments. So I use a red color pen to write here 118 degrees. And I found my angle ADC as they want me to find. If I need to find angle ACD, this one is simple compared to what we have done so far. Angle ACD is simply equals to 180 degrees minus 118 degrees divided by 2, because this is actually a isosceles triangle ADC. Then simply computing everything, you should get ACD is equals to 31 degrees. And that rounds up the exercise 10.3.